Hi, my name is Nur Farhanis binti Muhammad Najib. I'm from DEP2S3. So today I'm gonna explain a little bit about diode. A diode is defined as a two-terminal electronic components that only conduct currents in one direction, so long as it is operated within a specific voltage level. An ideal diode will have zero resistance in one direction and infinity resistance in the reverse direction. Although in the real world, diodes cannot achieve zero or infinity resistance. Instead, a diode will have negligible resistance in one direction to allow current flow and very high resistance in the reverse direction to prevent current flow. A diode is effectively like a valve for an electrical circuit. The symbol of diode is shown below. The arrowhead points in the direction of conventional current flow in the forward bias condition. That means the anode is connected to the P side and the cathode is connected to the N side. We can create a simple PN junction diode by doping pentavalent or donor impurity in portion and trivalent, or acceptor impurity in the other portion of silicon or germanium crystal block. These dopings make a PN junction in the middle part of the block. We can also form a PN junction by joining a P-type semiconductor and N-type semiconductor together with a special fabrication technique. The terminal connected to the P-type is the anode, and the terminal connected to the N-type side is the cathode. In forward biasing, the external voltage is applied across the PN junction diode. This voltage cancels the potential barrier and provides the low resistance path to the flow of current. The forward bias means the positive region is connected to the P terminal of the supply and the negative region is connected to the N-type of the device. In reverse bias, the negative region is connected to the positive terminal of the battery and the positive region is connected to the negative terminal. The reverse potential increases the strength of the potential barrier. The potential barrier resists the flow of charge carrier across the junction. It creates a high resistive path in which no current flow through the circuit. The forward bias reduces the strength of the potential barrier, due to which the current easily moves across the junction, whereas reverse bias strengthens the potential barrier and obstructs the flow of the charge carrier. In forward biasing, the positive terminal of the battery is connected to the P region, and the negative terminal is connected to the N-type material, while in reverse bias, the positive terminal of the supply is connected to the N-type material and the negative terminal is connected to the P-type material of the device. The forward bias set up the electric field across the potential, which reduces the strength of the potential barrier, whereas the reverse bias increases the strength of the potential barrier. The potential barrier is the layer between the PN junction diode, which restricts the movement of electron across the junction. In forward biasing, the voltage of anode is greater than cathode, whereas in reverse bias, the voltage of the cathode is greater than the anode. The forward bias has a large forward current, while the reverse bias has a very small forward current. The current in the diode when flowed in the forward direction is called forward current. The depletion layer of the diode is very thin in forward biasing and thick in reverse bias. The depletion layer is the region around the junction in which the free charge carrier are depleted. The forward bias decreases the resistance of the diode, whereas the reverse bias increases the resistance of the diode. In forward biasing, the current is easily flowing through the circuit, whereas reverse bias does not allow the current to flow through it. In forward biasing, the magnitude of the currents depends on the forward voltage, whereas in reverse, the magnitude of the current is very small or negligible. In forward biasing, the device operates as a conductor, whereas in reverse bias, the device acts as an insulator.
There is 5 IV characteristics for silicon diode, which is knee voltage, forward current, reverse current, breakdown voltage, and burning level. Knee voltage is voltage level where the increasement of current happen when the applied forward bias voltage reach the barrier voltage. Knee voltage for diode have two, silicon and germanium. Silicon is 0.7 volt while germanium is 0.3 volt. Forward current is amount of current that can be handled safely when the forward voltage is supplied. Forward current is measured in milliampere. Next, reverse current. Reverse current is very small current or leakage current when the diode is reverse biased. Reverse current measured in microampere. After that, breakdown voltage. Breakdown voltage is voltage level where the increasement of reverse current happen, and it is measured in microampere. Big current value exceed the breakdown level can burn the PN junction and damage it. Lastly, burning level. When forward current and reverse current exceed maximum, the component will burn.
For forward bias, diode has a closed switch which is on because no resistance and voltage drop, so the current can flow through it. For reverse bias, diode has an open switch which is off, infinity resistant, so there's no current can flow if the circuit is open.